Okay, let's do the second video on 11.4a. So what we have is we got two positive sequences where Bn is always bigger than An. Then we know that the series of Bn is always bigger than the series of An. Now suppose we want to do, we want to figure out what happens to n equals 1 to infinity. Let me see what I picked here. N squared over 4. So n squared plus 4. Okay, looking at that guy, you got to think, I want to compare this to a series, but I got to know something about the series that I'm comparing it to. If I don't know the series I'm comparing it to is either converges or diverges, if I got two series up here I don't know anything about, it doesn't do me good. But I got to compare it to something that I know something about. And first I got to make a guess. Well, what do you think this thing's going to look like in the long run? I'm taking n, I'm squaring, I'm adding 4 to it. After a while, the 4 is not going to make much difference. So I'm going to compare this guy to the summation n equals 1 to infinity of 1 over n squared. Now, does this guy converge or diverge? That's a P series. We know something about that guy. That's a 2. 2 is bigger than 1, so I know that guy converges. So let's look at the two guys. Let's look at 1 over n squared plus 4. Are these guys positive? Yes, they are. As long as n, that's always positive. Don't even worry about it. Those guys squared it. And what do I know about 1 over n squared? Who's bigger? Well, here I added something to the bottom, which made this guy smaller. So I know this is true. Okay, so what do I know about the summation n equals 1 to infinity of 1 over n squared plus 4? I know that's less than the sum n equals 1 to the infinity of 1 over n squared. And I know this guy converges, so I'll automatically know that this guy converges. Okay, let's look at another one that we're going to make blow up. Okay, so pick something. You got something you'll work on. Look at it. Find something you can compare it to that you know something about. And first you got to make a guess. I believe this guy's going to converge because I think it looks like that. 1 over n squared. Okay, let me pick another one. Show you how to make something blow up. Okay, so I picked another problem. We got the summation n equals 1 to infinity, and I got 6 to the n over 5 to the n minus 2. Okay, look at this guy. Do you think this is going to converge or diverge? What does it really look like? Well, to me, it looks like 6 over 5 to the n. 6 over 5 to the n, that's a, so this looks like this series to me. Okay. Does this converge or diverge? Well, that's a geometric series, and my ratio is bigger than 1, so this guy's going to diverge. Now let's compare these two guys. Let's look at 6 to the n over 5 to the n minus 2, and that'll be, you can write that as 6 to the n over 5 to the n. And now that's the same as this. And here I made the bottom smaller, so this guy's going to be bigger than that guy. This one's bigger than that guy, so I do know that summation n equals 1 to infinity of 6 over 5 to the n is less than this guy, summation n equals 1 to the infinity of 6 to the n over 5 to the n minus 2. I know this guy diverges to infinity. So this guy blows up. Well, this guy's bigger than that. It's got to blow up too. So with that, I can show without a doubt that that guy right there blows up. Now there's some holes in this, which I'll get to next time. But we'll have an even more powerful test I'm going to give you in the next video. But let me show you something real quick here. Suppose that you have something like this. You got summation an is less than the summation of beaten, and you know that this guy converges. Well, then you're going to know that this guy converges. If you had an error bound for this guy, so you use an integral test or something like that, and able to get an error bound for this guy, well, since this guy's bigger and this guy's increasing, that same error bound will work for this one. So you can use this guy's error bound to work on this one. Okay, that's enough for this video, and I'm going to give you some examples next time.